Moses, are you there?
Yes, I'm still here.
Perfect. And now you have your colleague there as well.
Yes.
Nicely distributed over the screen.
Yeah.
Yeah.
Okay, wonderful.
Yeah, perfect. And presentation mode.
Okay.
Thank you. Take it away. It's all set.
Okay, fantastic. So yeah, first of all, thanks a lot for giving us this opportunity to speak with you guys today. And so this is our first attendance at this Things event. So yeah, and it's been quite eye-opening. And so we work for this company, Remos, and we are based in the very northern part of Sweden. And we specialize in satellite telecommunications. So we provide the link between Earth and space. And we're going to explain exactly what we do in the next few slides. Okay, so the first question here is, what is the state of the space industry at the moment? And so we have seen that there's been a tremendous increase in the in use cases for satellites. And both of these missions actually, both of these satellites require ground stations in order to download this data from the satellites. And there are a lot of newer missions, and some of the missions, the newer ones, for example, Apogeo have been talking about IoT, so it's one of the growing industries. And we also have Earth observation, for example, which is responsible for providing critical information. So, for example, we took this photo here from Maxar. So this was one day before the Russia invaded Ukraine. And the second one here is from another company. So this was the beginning of the conflict in the Middle East. So we can see now that space has moved from the traditional area of doing maybe satellite broadcast into other areas that have proven to be quite useful for modern economies. And the space is also responsible for providing most of the data that we are using now for making all the models that are used for climate monitoring. Okay. Am I not sharing?
No.
Okay. Oh, I thought I was sharing. Okay, so what is happening again? So now also, in order to cater to this demand, there's been an increasing number of satellites that are being launched. And I think the first speaker hinted a bit on satellite miniaturization. So satellite miniaturization has been responsible for the meteoritic numbers of satellites that have been launched into space. And another trend is the decreasing launch of a satellite, because back in the days it used to be millions of dollars to launch a satellite, and with the new players like SpaceX in the scene right now, it has become relatively cheaper to launch satellites into space. And according to the report from Euroconsult, in 2021, there were around 4,800 satellites, and the projection is around 24,500 satellites until 2031. So what is the challenge? What is the problem? So the problem is that now satellite operators are facing the increasing cost and complexity of ground operations, because when you send a satellite, you always need to communicate with it. And now, since there's so many of them, and they're becoming more and more complex, then the ground stations have become, ground operations have become very costly and also more complex. And one of the reasons for that is the current architecture of the ground station. As you can see here, so you typically have a satellite and a ground station, which is an antenna, and a conventional stack for processing these signals and extracting the data from those signals. And since this is hardware based, it makes operations more expensive, and these are also not very good at scaling and redundancy. Given the fact that we have many satellites, then this also could translate into a high cost of operations. And so what is the solution? So the solution is to use what we call virtualized ground stations. So in virtualized ground stations, what happens is that we replace most of these hardware elements with software elements. And the software becomes very cost effective, and it's very easy to scale. And it's very easy to develop and deploy. And since this solution is purely software based, then it's very easy to support both the new as well as legacy missions. And finally, we are going to look into the adoption of virtualized ground stations, because right now there are too many classes. So we still have the traditional setup, which is very hardware centric, and we also have the virtualized setup that is software centric. And so the adoption for virtualized ground stations is not is ongoing, but at a high rate. And some of the traditional players are still using the traditional setup, which is very hardware centric. And this translates into a high cost for operators, and it's also very hard to make to achieve redundancy. And the main users for this include the military, government, and emerging space nations, as well as incumbent companies. And the reason for using this is that it's inherently more secure, and it's also they have the necessary legacy for them to be trusted to do critical missions as well as exotic missions. So, for example, if you want to send a probe, an interplanetary probe, it's better to use this traditional setup that has been approved for the past 50 years. And on the right-hand side here is where we have the virtualized setup, whereby all the signal processing is done in a cloud. And so there are two many players in this. So we have those players that use the public cloud. So this is the likes of Amazon and Microsoft Azure, and these are the new entrants. And we also have other traditional players that are actually trying to adopt this architecture. And the most prominent one is KSAT from Norway, and to some extent we have the LiftSpace from Italy. And so we are a relatively new company, and we have already deployed some of these solutions in various parts of the world. So, for example, we have a couple here in an American customer here based in Sweden. We have deployed some of our systems at DLR in Germany, some systems in Mexico for the Mexican government, for the Ecuador, as well as the university here in northern Sweden. And finally, a little bit more about ourselves. So we are a spin-off from the Luleå University of Technology and the Swedish Space Corporation. And we were founded in 2021. So we are relatively fresh. So we are only 2.5 years now. And we have been part of ISABIC Sweden, as well as the Arctic Business Incubator. And currently, we are part of the EU Cassini Accelerator Program. And we've already have around 8 customers, customers in almost 8 countries now. And we secured our pre-seed round in 2021, and we are planning to raise a seed round in early 2024. And so this is our team. So myself, I'm the CEO, and my background is in this particular area, whereby I did a PhD with the Swedish Space Corporation. And we have our colleagues here, like Tilini, who works in international business, and we also have my colleague Peter, who is with me. And this is our board. So we have our good friend here, Marcus, and he's the founder of NetRAM. So this is a company here in northern Sweden that's now acquired by Juniper. We also have Mustafa from Sat Consult, and Krista, who you might know, who is an expert in space and military communication based in Stockholm. So yeah, so that's all. So thanks a lot for listening.
Thanks a lot, Moses. Very interesting and very good. Let me see. I have no questions for you here. And I don't have any specific questions myself either. So I think we leave you there, and thank you so much.